Well, greetings, everybody. Here's a question that came to my attention this morning on conditional probability and the multiplication rule. And the way I want to approach this question for now is just that this formula is given to us, and we're just going to accept it and work with it, okay? And I want to focus on this part right here that says P, and then there's a B, vertical bar, and then an A. Now that's conditional probability. And the way that we would read that is it says the probability that B happens given that A already happened. Okay? Now, I'm given some other data here that the probability that plane flight departs on time is 89%, and the probability the flight arrives on time is 88%, and the probability that a flight both departs and arrives on time is 84%. Okay, we'll deal with those numbers in a minute. But the question is a question about conditional probability. Look at how it reads. It says the probability, what is the probability that a flight departs or departed on time given that it arrived on time? That's conditional probability. Remember how I read this? This says the probability that B happens given that A already happened. So I'm going to translate this question. I'm going to write it this way, okay? I want to know the probability that a flight will depart on time given that it has arrived on time, okay? All right, now I've got a formula that will calculate that for me. That's this part, okay? Now I'm going to name these events instead of having to write them out again. So this will be event B and this will be event A. And so the way I'll calculate this is it's the probability that A and B happen together divided by the probability that A happens. Okay? So this top part right here, probability of A and B, that would be the probability that a flight departs on time given that it arrives on time. And that's this part right here. Do you see the probability that a flight departs and arrives on time is 84%? Okay, so that's 84% there on top. And then I divide by probability of event A, where event A is that the flight arrives on time to begin with. Okay, so I gotta look up here. This middle one, the probability that a flight arrives on time is 88%. So there you go. All I had to do was understand that this is conditional probability in this formula, and that's the part of the question that I'm being asked for is a conditional probability. Then I just had to name the events and fill in the rest of the formula. Dividing it out, I get 0.955. I write that because it says round to the nearest thousandth. That's 3 decimal places. Okay. All right, so that's conditional probability. Let's make sure we recognize the notation and just get it in your head the best you can whenever you see it, that this event A here has already happened, and we're trying to figure out, as a result, what's the probability that B is going to happen. All right, that's always how I'll read and understand conditional probability. So I'll leave it with you one more time. Looking at this right here, interpreting this as conditional probability, I wanted to know the odds that a flight will depart on time given that it already has arrived on time.